All right, guys, welcome back to the last video of the 3 series for scientific notation. So now we're going to cover addition and subtraction. So here, it's different than multiplication and division. It doesn't actually follow any of the laws of exponents here, because all you have to do is just make sure that your powers of 10 are the same. So remember the steps is, you want to see if the powers of 10 are the same. If they're not, then adjust them so they have the same exponent. And then you're going to add, subtract the numbers, and then you're going to give your answer in scientific notation. So the first one in the PowerPoint, I have 2 times 10 to the negative 11 plus 1.433 times 10 to the negative 11. I see that my powers of 10 have the same exponent, so I don't have to worry about that for this example. So all I have to do is add, subtract the numbers. So 2 plus 1.433 is going to be equal to 3.433. And then lastly, give the answer in scientific notation, times 10 to the negative 11th power. And that is my answer for the first one. For the second one, it gives me 5.671 times 10 to the 5th power minus 4.08 times 10 to the 5th power. Once again, my exponents are the same. So this is fine and this matches that. So all I'm going to do is subtract 5.671 minus 4.08. Let me pull up a calculator and let me do that really fast. Where did it go? So I have 5.671 minus 4.08. So that gives me, let's see, 1.591 times 10 to the 5th power. So the next couple ones are where it gets difficult. And that is because we kind of have, we have to change the base 10 because they're different. So for number 3, I have 2.03 times 10 to the 3, or 10 to the 3rd, plus 3.214 times 10 to the 4th power. So the first step is adjust the powers of 10 so they have the same index or exponent. So what I'm going to do here is, I typically find it easier to see the one with the smaller exponent and adjust it so it matches the bigger one. So here, I'm just going to move the decimal one over to the left and have 0.203 times 10 to the 4th. 1, 2, 3, 4. 1, 2, 3. So those would be the same. Parentheses. Plus 3.214 times 10 to the 4th. So now that my bases and exponents are the same, I can just add these two together, and I get 3.417. And then I just give the answer in scientific notation, times 10 to the 4th power. So, let's see, I am running out of room, so I'm going to grab another sheet of paper and I'm going to fold it in half so you guys don't see everything through it. All right, so for the last one, it gives me parentheses 6.15 times 10 to the 7th power minus 3.56 times 10 to the 5th power. So once again, what I'm going to do is I'm going to find which one has the smaller exponent, and I'm going to change that one to match the bigger one. So here I'm just going to rewrite 6.15 times 10 to the 7th, parentheses, minus, and I'm just going to move this over 2 because, or this decimal point over to the left by 2. So 1, 2, 0, 3, 5, 6 times 10 to the 7th. And I moved it over by 2 because 5 plus 2 is 7. I'm trying to match 7. So now that my bases are the same, what I'm going to do is subtract. So let me pull up a calculator because that one I can't do in my head as fast as the easier ones. So 6.15 minus 0.0356. So this one is going to be 6.1144 times 10 to the 7th power. And that's my answer for that one. All right, hope y'all enjoyed.